Okay everyone, in the last video we left off with this problem and we figured out what the exponential model was for this particular data, but now we have to answer the second part of the question. When will the number of bacteria reach 2,000? Remember that the bacteria number is our y value, right? This is our x values, these are our y values. So we're trying to find what x is when y is 2,000, right? What is this value here when y is 2,000? So in our calculator, we stored that equation in y1, and so in y2, just like we did in the previous example, in y2 we're going to put that that y value that we know. In this case it's 2,000, and so we're going to find the intersection of these two graphs to get the x value. Okay, so if I go ahead and hit zoom, and then go down to zoom stat, and I graph that, here's what I have. So here is that y1, and you'll see here that it's done graphing because that little icon there, that little line there is gone, but you don't see that line, that horizontal line y equals 2,000. So here's where you have to start really getting into changing things in the calculator so that you can see what you need to see on the screen. And what I mean by that is this. If you go to your window, and right now, look at what our Y max is. So this is what our screen is seeing right now. Our Y max only goes up to 679. Okay, I need it to go up to 2,000 at least. So I'm going to actually change that. I'm going to change my x too, because my x is going to be greater than 5.5 if this is up at 2,000. So what I'm going to do is, and it's a little bit of trial and error really, I'm going to change this to 10, and then I'm going to change my y max. I'm going to go above 2,000. I'm going to go up to 2,500. The only reason I'm going above 2,000 is I don't want it to be at the very top of the screen. I want it to be down a little bit so I can see. Okay, so I just adjusted those numbers by pressing the window button, and then I pressed graph, and now I see, okay, almost can see where those lines intersect. So now I'm still going to need to adjust to my x value. I have to increase my x values in my window. So right now my window only goes up to 10. I'm going to change that to 20. Let's see if that works. I'm going to graph it again. And so here's my graph. And you'll see the other one come up here. And now I can see where my two lines intersect. And now that I can see that, I can use the intersect function. So I'm going to hit second trace, go down to option 5. So you can just press 5 for intersect, or you can arrow down and press enter. I'm going to just press 5, and then you're just pressing enter 3 times. 1, 2, 3. And you'll see when y is 2,000, x is roughly 10.3. So when will the number of bacteria reach 2,000? In about 10.3 minutes. Okay, so I'm going to write that down. So x is equal to 10.3. So x is approximately equal to 10.3 minutes. Okay, if you're not sure what I did, rewind the video and walk through that again. Remember, there was some changing of the window in the calculator, and you'd get that by pressing the window button. Okay, and all I did was change my x max and my y max so that I can fit these values in so I could see where those lines intersected. Okay, so that's how you're going to approach those exponential regressions. We're also going to talk about logarithmic regressions. This one in particular is talking about the Richter scale and TNT equivalence, okay? Talking about explosions, right? Always fun stuff. So we're going to go ahead, just like we've been doing, and putting this stuff into the calculator. Now notice here it says find a natural log. So this is no longer exponential. This is now a natural log. Remember, natural log is just log base e. It doesn't really change anything, we do this right in the calculator, just like we've been doing all the other problems. So I'm going to go back to Stat, and then I'm going to press Enter on Edit, and I'm going to clear out my data. Clear and Enter, and then if I go up to the heading and press Clear and Enter, I get rid of all of that data. Okay, I'm going to pause this video, and I'm just going to go ahead and enter the data into my calculator. Okay, I have all of that data entered in. You'll see it started with 1 ton and then 30. Those are 10 each, and then that's 1,000, and then these are 10,000 each. So that's where the 1, the 30, the 1,000, and the 30,000 came from. Oops, those are my X values, and then my Y values are the magnitude. Those are my Y values. Now, it says to do a natural log regression. Before I do that, I'm going to clear out what I have in my calculator already. I'm going to go to Stat, and I'm going to go over to Calc. Now, with the last problems, we did the exponential regression. Here, we're going to do natural log regression. That's that ln reg. Okay, that's option 9. So you're going to press Enter, and then you're going to do the same thing we did before. Vars, Y vars, Enter, Enter, and then Enter again. And now we have our equation, a plus b ln of x. They gave us an a, and they gave us a b value. So y is equal to a plus b ln of x. So y is equal, so I'm just getting this information out of the calculator. Y is equal to 2.00 is our a value. So 2.00 plus our b value, which was 0.29, so plus 0.29 ln of x. That is our model. Okay, now again, remember these are our x values and these are our y values, and they want us to figure out how much TNT we need to get 6.5 on our Richter scale. So to get a y value of 6.5, what is the x? Okay, again, to do that, let's go back to y equals, and y2, I'm going to put in 6.5. Again, pause your pause the video and enter stuff in your calculator if you need to. Okay. Now, if I go to Zoom and I go to Zoom Stat and I press Enter, now notice here what happens. Okay. I see my linear regression, but I don't see my horizontal line. So go back to your window. Okay, in your window, look what's going on here. My y max only goes up to 5, but I need it to go up to 6.5. So I'm actually going to put this at 7, just because I like to go a little bit higher than what they have. Okay, now, also, I can go ahead and graph this, but here's what's going to happen. Our lines aren't going to intersect. This x is 30,000, and look at this huge difference between these two. So I have to go way, way, way out on my x-axis to figure out where these two are going to intersect. If you look at your table, right, if you look at these y values and look at where they are, I can scroll down and look at these y values are getting they're increasing very, very, very slightly with each increase in my x value. Okay, so I'm going to have to really do a lot of changing. Let's say I change this to 100,000 and I were to graph it. See what happens. Look, I haven't really gotten much closer. So I'm going to have to try something else. So let's go back to the window. Let's try 1,000,000. 1, 1, 2, 3, 1, 2, 3. Let's graph that. So it looks like we're getting closer, right? But we're not quite there yet. Let's try, you can try whatever. I'm going to try 5,000,000. 3, 1, 2, 3. Let's see if that gets us anywhere. Oh my goodness, we're so close, right? We kind of really can't see where they intersect, but we're really close. So I'm going to go back to my window. Maybe I'll try 6 million. Let's try that. 6, 1, 2, 3, 1, 2, 3. Let's do that. And I think we're probably going to be okay. There, you can kind of see where those two lines intersected there. So now we can go ahead and we can do second trace, option 5, intersect, enter 3 times. And you'll see here you get 5308861.5. So 530, so x equals 5308866, I think it was 65, is that what it was? 8861.5. 8861. Okay, so that's, let's see, that's like 5,308,861.5. So it's roughly about 5.3 million tons, I believe. Yep, 5.3 million tons of TNT is needed to get a 6.5 magnitude, right? That's pretty big. That's pretty hefty. Okay, so very similar to what we were just doing. Again, you're just adjusting your window size. So let's try this last one. It says use this to get a logarithmic regression. Okay, again, I'm just going to go to Stat, Edit, and now I'm going to clear my data out, and I'm going to enter this data in. I'm just going to pause the video and take care of all that. I'll be right back. Okay, I have all of my data entered in. Now, they're asking for a logarithmic regression. It doesn't, in this problem, it didn't say natural log, but you can still use the natural log regression option. Okay, so if you press Stat, go over to Calc, and you're going to go down to option 9. It's the only logarithmic regression that's in here, so you have to use that one. And it's fine to use it. And we are going to store it in Y1, so arrow to vars, enter, 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 and we get our function. It's y is equal to 0.59 plus 2.6 ln of x. Okay, y equals 0.59 plus 2.6, I can't remember what I said, 2.6 ln of x, 2.6 ln of x. Okay, that is the model, and now we have to take care of part B. So what is the time when this is equal to 8? Just like we were doing our other problems, I'm going to go to y equals, and in y2, let me clear that out, I'm going to put in 8, and then I'm going to say zoom, and I'm going to do zoom stat, and here's my graph. Again, you're not seeing this y equals 8, probably because my window doesn't go up to 8. It only went up to 6, so I'm going to actually do it up to 10 for the y, because I need it to be at least 8. And for my x max, I'm gonna try going up to 20, just to see if, right, it has to go up to at least 7. It's going to probably have to go some more. It has to be something greater than 7. I'm going to put it up to 20 just to give myself some room. And let's see if that gives it to us. And you see there they do cross, so you can go to second trace, option 5, press enter 3 times, and you'll get that point. When y is 8, x is about 16.6. So it's about 16.6 minutes. X is about 16.6 minutes for this speed to reach 8 meters per second. You can see it's written right there on the screen for you. Okay, everybody, so that's how you're going to do the problems on that on the assignment sheet tonight. You'll see everything is laid out very similar to what we just did here. Should be all set. I'll see y'all in class tomorrow. Take care, everybody. Bye-bye.